Today, we will discuss quantum computing technology for material science. Why material science is important and how can we apply quantum computing technology for material science. In every field of science, engineering, or others, we use material science. And the quantum computing technology is the most advanced technology today. And we need to apply in the field of material science. And how can we do it? Today, we will discuss it. I prepared some slides to presentation about quantum computing technology for material science. Why this is important? Why quantum computing technology is the biggest challenge for the material science and how is it works. For the introduction part, I prepared the quantum computing technology. I will give some short information about the quantum computing technology because it is very deep. It is very deep topic about advanced technology, but I will give the short information about that. And after that, we will discuss the power of computing, how this is how it is possible, and how we are use the qubits or classical computer. What is the difference between classical computers and the quantum computing? And the power of computing is very essential, very important for the material science. And in the main topic, the material science and power of computing. How can we apply this technology in the material science? And how we can change the power of computing in the field of material science? And different industries and studies. I will give some example about that. And after that, material science for quantum technology. We design different materials for the quantum computing technology. And quantum computing technology will design different materials. It is very complicated problem for science today. But I will give some short of information and I will give some brief talk about it. After that, we will make a conclusion. And the quantum computing technology, this technology is the most important scientific discipline of our century and our future. Why I'm saying like that? Because it is the most advanced technology. Because we can achieve the most computing power of computing with the quantum computing technology in the material science. We can design any material. We can make anything with the quantum computing technology. This technology is the basis of the systems that can achieve high computational capability with the help of qubits. It is very different between the classical computer and the quantum computing because there are many qubits. There are superposition in the qubits. We can apply in the gates, in the different algorithms in the quantum computing with the help of the qubits. And we can solve many complex problems with the help of the qubits. And the inherent parallelism of quantum computers comes from the superposition of qubits. This parallelism allows a quantum computer to work on a million computations at once. It's very important because this is the huge amount of computational power of qubits. And we can achieve the thousands of qubits today with the help of IBM. It is very important scientific news. This technology can fulfill high accuracy and computational capability with different algorithms and a completely different concept of information processing. It is very different to use quantum computing technology in accordance with the information process because you need to design your algorithms, your gates, and your problem in this field of computing. This technology creates its own ecosystems with 5 different qubit models, different algorithm schemes, problems, and solutions. As I said before, this is a new concept, and we need to design the material science in this field. And we can achieve anything, we can make anything with help of quantum computing technology. And the power of computing, it is the main idea of the quantum computing technology, because we can make a solution for the complex problems with help of the power of computing. How we are take this power of computing? Because of there are qubits. This technology brings with it the computational power unimaginable to mankind. Because, as I said before, we already reach more than 10,000 qubits due to the IBM works. This process capability increases exponentially as 2 power of n depending on the number of qubits. For example, at 30 qubit quantum computer would equal the processing power of a conventional computer that could run teraflops, trillions of floating point operation per second. Today's typical desktop computers run at speed measured in gigaflops, billions of floating point of operation. But that amount of power of computing, it is very unimaginable. And how can we use in the material science? I will show you. This image show the 10,000 qubit processor image D-wave systems. Also, D-wave has a very good work about the quantum computing qubit processor. How can we obtain the qubits, and how can we apply the qubits on the problem? With the different algorithms, with the different gates, how can we solve this problem? And how can we apply in industry? The next slides, we will discuss the material science, how it's related with the qubits. And this is the amount of qubits of IBM, different years, we reach more than thousands in last year. It is very important and big news about it, because that amount of qubits gives us the unimaginable calculation capability, power of computing capability. And material science and power of computing. In the material science, defining the specifics of materials, structure, property, process, and characterization are taken into account. We can design our polymers, our ceramics, our metals with the processing, performance, structure, properties, and characterization values. We can combine them with new materials and achieve high performance materials and very different nanomaterials. And we can obtain different shape of structure. We can obtain different processing of materials. We can obtain higher performance materials with the change of atomic structure, with the change of molecular arrangement, and with the change of movement of molecules in the polymers. For example, when I give the pyramid for the polymers, we can change the movement of the polymer chain. We can change polymer thermodynamics of the polymers. And how can we process about this thermodynamic processing? Because there is a huge amount of problems in the side of mathematics. This is the power of computing we can apply. We can make a calculation. We can achieve the more and more high performance materials. Because we have the qubits, we can solve many problems. It is very important. Each parameter is carefully selected and combined to determine the performance of the materials. You can make different alloying elements. And how can we solve the different kinetics of materials parameters? We can create a new material, and you need to make simulations. How can you make simulations? You can't even imagine the amount of the problem. This is why we are using the qubits. This is the power of computing with the quantum computing technology in the material science. We can solve many problems in the material science. We can design kinetics of materials. We can make relations in the thermodynamics process. And this can help us to design our materials thermodynamically, in the atomic structure, in the performance of the materials. in nanoparameters or macro parameters. It's very important. And there are many different industries and studies about this. The pharmaceutical companies have devoted a growing share of their net revenues to R&D activities, averaging about 19% over the past 2 decades. By comparison, other research-intensive industry like software and semiconductors average about 15%. This is very important. Pharmaceutical companies can apply the material science is the main factor why they are applied the quantum computing technology and the power of computing in the pharmaceutical industry, and why we are design new semiconductors. How can we do it? Because there are big problem inside the atomic structure, thermodynamically and atomic arrangements, and many calculations. We need to solve this problem. But accuracy, and you need to be fast. And that's why the qubits help us. And different industries and studies, I will give the pharmaceutical industry. And quantum computing's primary value for pharma lies in research and development. Disease understanding and hypothesis development, target finding. This is very important to use quantum computing technology to competing with power of computing, because this industry is growing very rapidly due to material science. In order to design materials, collect appropriate data, and ensure chemical and physical stability, the big data network must be analyzed quickly and the right decision must be made. The pharmaceutical industry stands out as the important area where quantum computers and material science are combined. This situation grows even more with financial data and investments instruments. This is very important because in the chemical and the physical tests, during chemical and physical tests, there are millions of data according to drugs and crystallization ratio and optimization ratio or anything, the analysis of the chemical structure. How can we solve this problem easily? And you need to give good decision about the pharmaceutical industry because it is a very important industry. You need to be very fast. For example, pandemic and the COVID-19. You need to make good drugs. And how can you do that? Because you need to combine many things in the drugs. And there are 4 stages in the pharmaceutical industry to make a good drug. And this is why we are using this method and the quantum computing technology. And this is very important for this industry. And also, there are other industries, for example, semiconductors. As the semiconductor industry, according to in the research in the 2000 previous slides, you need to grow your crystalline structure in the semiconductors. How can you apply at the pressure level? The pressure level is important, and atomic structure is the most important part because the stability of the electrons and the band gap, it's very important. It is another parameters. There are billions parameters, and you need to combine these parameters very fast. This is why we are using quantum computing. The pharmaceutical industry is a significant contributor to the global economy and to health systems and healthcare across the world. According to data from IQVIA, revenue in the global pharmaceutical market is estimated to have reached 1,482 billion American dollars in 2022. Why the financial growth is important for the pharmaceutical industry? As there's a COVID-19 and other disease in the world, and you need to find a good solution. And how can we apply the computing power of computing? we need to measure the drug crystallinity ratio, solubility optimization rate, and the product formulations in the organic product formulations. You need to know the material science, and you need to be quick. You need to be solve your problem as possible quickly. And that's why you need to apply the competing power of competing, because you need to know solubility optimization. You need to change ratio of crystallinity in accordance with disease. You need to change product formulations in accordance with body, in accordance with disease. You need to be quick. That's why we are using the qubits. And then we need to examine the other side of science, accordance with material science in the quantum technology, material science for quantum computing technology, and how can we apply the materials in the quantum computing technology. And this is the other side of this technology. The electrical properties is one of the most important parameters for the quantum computing technology, because you need to obtain good photons. The photonic properties is very important in the semiconductor materials. You need to design your materials, especially two-dimensional materials is important to achieve more and more stable photons. When I continue in the slides, electrical properties of materials emerge as the most important property for quantum computers. Different structures and materials groups can exhibit different electrical properties. It's very important. There are many semiconductors in this field, and the different corporation and different industries work with different materials. I will give three of example in the next slides, and especially the evolution of two-dimensional materials in terms of photonics is extremely important for quantum computing. And one of them quantum dot technology, and others broadband technology. It is very important to design the band gap, and the broadband technology is important to design your band gap to take the photons in the for example, trapped ion system. It is very important and essential for broadband technology, for bandgap systems, for trapped ion systems. On the other side, quantum dot technology is very important for the superconducting quantum computing technology. And this is why important, because these are different technologies use two-dimensional materials for the stability of the systems. You need to design your materials in the nanometer scale as possible as good arrangement and good appropriate electrical characteristics. It is very important to combine different materials for the semicrystalline materials, because you need to obtain good purity of the photon. And also lifetime is important, because if you take the photons, you need to be processed with this photon. This is the lifetime of the photon is the essential. And there are some parameters about that. For example, superconductors materials, in the most important parameters is the operating temperatures, because the operating temperature is the source of the energy. It is very important to obtain good operation temperatures to available systems, to common systems. You need to achieve, for example, minus 100 degrees Celsius for the photons, because the cryogenic temperature is very hard to make operation in the system, because the cryogenic temperature is the waste of time and waste of energy, a big energy and a big time. It is very important to obtain cryogenic temperatures for the photonic systems. On the other hand, lifetimes, emission wavelength range, And the photon purity and the band gaps of photons is the most important parameters for the photonic characteristics of the materials. Thus, the development of material science directly affects computer technologies. And then I, I will give some different materials and their values in terms of photonic properties. For example, molybdenum sulfide, tungsten, selenium, and the molybdenum selenium. These are different materials, shows different characteristics, different photonic characteristics. As you show, the lifetime is too short. This is very important to make a process in the quantum computing technology. You need to achieve to protect your lifetime, your photons, to process range. This is very important to design algorithms on the quantum computing system. Because of lifetime, if you have good lifetime, you can make a processing time. You can have good processing time. It's very important. So also, emission wavelength range is important to work specific parameters for the system, because every photons have different emission wavelength range, and you need to simulate your system in the field of emission wavelength range. This is very important to work with different semiconductors. And also purity of the photons. I will give some examples about these materials for our work. And the purity of the photon is important to obtain more clear information from the photons. This is also important. And the operation temperature, and I said before, operation temperature is important to apply this technology in this in the industry, because cryogenic temperature is very hard to obtain that for the industry and every field of the life, and you need to obtain good temperature, good operation temperature to your process, to your system, for work. It is very important because temperature is the cost of energy. The mainly cost of energy is the temperature. You need to make a good setup about that. And the band gap is important to arrange the electron volts between the minus and positive and minus, and p-type and for n-type. And this is very important and technical issue for the obtain the photons in this field of quantum technology. And when I make a summarize, in the summary, quantum computing technology have been used to determine the critical properties of materials. This has had a direct impact on the development of high-performance materials, especially in the pharmaceutical industry. As I said before, the pharmaceutical industry in the financial link is the most important area which depends on the quantum computing technology. Because, as I said, as you remember, the solution ratio of crystallinity, solubility, and formulation are very important parameters. You need to be quick about that. You need to gain good accuracy about that. In the pharmaceutical industry, the use of quantum computing technology has become widespread for processes that develop high computational technology, such as finding the solubility ratio and appropriate dosage. Today, the number of qubits has exceeded 10,000 by IBMs. It is very important volume achieve advanced technology. There are many sectors and there are many corporations in this field. And this number is increasing by day by. In order to increase this number, different materials have started to be developed in terms of photonics. The photonics is the main section for the material science for the quantum computing technology. For photonically developed materials, values such as operating temperature, band gap, and purity of the photon are very important. Why we are using these are factors, and I discussed. And these are parameters, is the technical parameters, and I don't give any technical information about that, but it's a little bit short talk, and I'm very happy to discuss these are parameters with you. All the factors within the ecosystem material science, quantum computer technologies, and the growing industries connected to them are growing in terms of financial and usage areas. As I said before, we are going to quantum age with the material science. And how can we apply the material science in the quantum computing technology, and on the other side, quantum computing technology for the material science? These are parameters is essential for the quantum age. And these are parameters: photonic behavior, two-dimensional materials, pharmaceutical industry, and also high-performance materials. They are related with the information technology. And maybe next day, on the next year, we need to obtain more than thousands qubits because our problems getting complex and we need to solve this in the field of the science. And I just want to say thank you about presentation and thank you for us.